right, now what we're going to do is use the laws of logarithms once again, but this time we're going to expand and simplify this expression. Okay, so division bar indicates what? Division bar indicates subtraction of what we're taking the logarithms of. So it's going to be the natural logarithm of e to the x. That's, what was in the numerator, e to the x, minus the natural logarithm of what? Of the quantity, of whatever was in the denominator here. So 1 plus e to the x. Okay, now there's an identity that's happening right now. It's right here, the natural logarithm of e to the x. What this is going to give us is just whatever is in the exponent position. So x minus ln of 1 plus e to the x. Let's take a look at why this is just equal to x. So it stems again from the definition of a logarithm. All right, so let's take a look at that now. All right, so I went ahead and wrote down y. If you have y equals the natural logarithm of x, then you also have e to the y, because remember the understood base here is e. You have e to the y equal to whatever you're taking the logarithm of. So let's just use some basic substitution here, okay? Let's go ahead and replace this x with what it must be equal to in this exponential form. So if we do that, we get what? We get y equals the natural logarithm of x, which again, these are happening simultaneously. This is an if and only if statement. So I'm now going to use substitution and replace this x with what x is equal to, which is e to the y. So notice y equals the natural logarithm of e to the y. Look, whatever was in the exponent position here, that's what you get. Exponent position here, what's there? A y. What's this equal to? Y. Okay? So there's another one as well, but this is the one we just used in this example. The other one would be replace y with what it's equal to. So this would be e to the, what's y? Natural logarithm of x must be equal to x. So these are inversely related, okay? The natural logarithm and the base e, they're inversely related. Okay, so you're just going to get, in this case, the exponent, and in this case, whatever you're taking the natural logarithm of. All right, let's finally look at solving some equations that are based on logarithms. We're going to put some things together here, okay? Use the laws of logarithms to solve the following equations. So for this first one, I'm just going to apply the definition of a logarithm, all right? So how do I do that? Well, what do we know? This is your base, so x to the what? Remember, a logarithm is an exponent, so x to the negative 2 is going to be equal to whatever we're taking the logarithm of, which is 1/16. Now it's just a matter of solving this thing. All right, so how would I get rid of this negative 2 in the exponent position over here on the left? Well, you could multiply both sides. You're not really multiplying, excuse me. You could raise both sides to the power of the reciprocal of this. So I'm going to raise both sides to the negative 1/2 because it's the reciprocal of this given exponent. And if I do that, then now is where I multiply. Now is where I multiply. When I do the multiplication here, power of a power, you just get what? You get 1. So you get x to the first, or just x, equal to whatever this is. Now, you can use your calculator at this point if you want, but this is the same as what? 1/16 is the same as 2 to the negative 4. Okay, you should be familiar with powers of base 2, especially. All right, so 16 is 2 to the 4th, 1/2 to the 4th, same as 2 to the negative 4, still to the power of negative 1/2, which means what? X equals power of a power is what? Multiplication. So you get a 2 here, right? Negative 4 times negative 1/2 is 2. So x equals 2 squared, which is 4. Final answer, x equals 4. All right, let's look at number 2. Here we have a difference of two logarithms. So we have to apply what? The second property, or second law, excuse me, of logarithms, which states what? When you subtract two logarithms, you're actually doing what? You're looking at a single logarithm to whatever the base is of the quotient of whatever you're taking the logarithm of, which would look like that. Okay? At this point, I could apply the definition of a logarithm, and I could rewrite this. So I'm going to go ahead and rewrite this now. So this logarithmic equation exists if and only if what? Base 5 to the first power, remember, logarithm is an exponent, is equal to whatever you're taking the logarithm of. So 2x plus 1 all over x minus 2. Now we just have a basic equation, which I hope we could solve for x. So I'm going to multiply both sides of this equation by x minus 2. That's our LCD. So I'd get 5 times the quantity of x minus 2 equaling 2x plus 1. All right, I just multiplied both sides by x minus 2. And then I would get what? Distributing the 5 through would give us this. And then we would do what? So this is basic now, I hope. I mean, subtract 2x from both sides. It's going to be what? 3x. And then if you add 10 to both sides, you get 11 over here on the right. So finally, we get x equals 11 thirds. All right. One thing you do want to be careful for, or careful about here in these logarithmic equations is going back to the properties of logarithms. You have to understand that you cannot take the logarithm of 0 or a negative value. So you got to make sure that the answers you get, if you were to plug them back in, you do not get 0 or a negative. Otherwise, it's not definable. Okay, but so far we're in great shape. All right, number 3. So, well, what can we do here? We're trying to solve for x. We're trying to isolate this x. So let's do this. Let's first multiply both sides by this denominator, just like we did in number 2. At this step, we really multiplied both sides by the LCD. So in example number 3, the LCD is this, 1 plus 4e to the 0.2x. So if we do that, we get this, 50 is equal to 20 times 1 plus 4e to the power of 2/10 x. Okay? And now what we're going to do is, well, we're going to think. What would be the easiest route? Would it be to distribute the 20 through this? Or you have a multiplication operation occurring right here. So you could just divide both sides by 20, and that's exactly what I'm going to do, because I think that's going to be easier. So I'll show you what I'm doing for this next step. I'm going to be, again, dividing both sides by 20. And what I end up with is 5 halves equaling what? 1 plus 4e to the 0.2x. I'm trying to get this x alone. Okay, now what am I going to do? Now I'm going to subtract 1 from both sides. I'm going to subtract 1 from both sides. So if I do that, what do I get? Well, I'll show you right here. 5 halves minus 1, that's 5 halves minus 2 over 2, which is 3 halves. So we get 3 halves is equal to what? Ooh, we're looking better. We're looking better here. Equaling 4e to the 2/10 x. All right, now I got to get rid of the 4. How do I do that? Well, you're going to divide both sides by 4. Okay? Now, when you divide both sides by 4, that's the same as what? Multiplying both sides by 1/4, right? So I'm going to show it like this on the right, 4 divided by 4, but on the left I'm going to do this. It's the same thing. Notice where 4 is located, in the denominator, okay? So, anywho, this cancels out. You end up with 3 over 8 on the left, and then e to the 2/10 x on the right. Now, what did I show you a little bit ago that would help us to get this x out of the exponent position and in the base position? Did I show you something? I believe I did, and here it is. Here it is. If we could take the natural logarithm of e to the something, we're going to get that something. That's important that you understand that. So here it is. If you have a situation like this, you want to take the natural logarithm of both sides so that you can use this identity that's occurring right here on the right to rewrite this whole thing as simply 0.2x. Okay, so again, if you're trying to get rid of an exponent, all right, it's base e raised to that exponent, you just have to take the natural logarithm of e, and then these will cancel, and you're going to be left with whatever the exponent is. Last thing we got to do here is just simply divide this thing by 2/10. So, I mean, you can look at this in different ways. You could say it's exactly 5 ln of 3/8, because when you divide by 2/10, same as dividing by 1/5. When you divide by 1/5, it's the same as 5 times this. So the exact answer would be 5 times the natural logarithm of 3/8. But you'll probably be rounding this, so let's go ahead and look at our calculator. So I'll just enter it in like it is right here, okay? So here's what I'm going to do. I'm going to do the natural logarithm. The natural logarithm button is right here. The natural logarithm of what? 3/8. Natural logarithm of 3/8. Okay? Then I'm going to divide this by 2/10. All right? And then let's go ahead and round this out to the nearest 10,000th, or 4 decimal places. So if I'm going to take this out 4 decimal places, I get x is approximately what? Negative 4.9041. Okay, that's probably how you'll be asked to enter it in WebAssign, out 4 decimal places. All right, we have one more example to look at.